Hey everyone, I'm Francisco Salazar, but you can call me Fran. In this video, we'll explore how to animate 3D models in Metaspark. In this occasion, we'll be focusing on models with a single animation. So, let's get started and bring your models to life. Before we dive in, let's talk about some important things you need to know. If we go to the Learn section of Metaspark website, we can find a lot of information we need to know about managing 3D models in Metaspark. From all of this info, here are the key points to keep in mind. It's better to use FBX or GLTF files. Get the right scale in meters. Make sure your models aren't smaller than 1 cm or larger than 5 meters. Set the object's origin point to the center of its geometry. Keep the total triangle count per object below 50,000, and for all objects combined, make sure it's under 150,000. While there is no strict limit on the number of phones you can use, it's recommended to use as few as possible, so less than 20 will do the trick. Keep each phone a separate name, and follow a consistent naming convention. Use a frame rate of 24 frames per second in the 3D software you're working in, and only add keyframes to standard properties, which are position, scale, and rotation. Now that we have covered these tips, let's jump into the 3D software to take a look to the model I have prepared. Okay, so here we are in Blender, and for our example, we're going to work with this robotic arm that I created for an effect. You can find the link in the description below. Feel free to check it out. As you can see, this model has a single animation that works perfectly in a loop. Now let's ensure it meets the requirements we discussed earlier. Rotation, position, and scale are affected. Triangles are below 50,000. Model size is less than 5 meters. Pivot point is set to the center of the object. The model has less than 20 bones, and each bone adheres to the naming convention. And if we head over to the output properties, you'll notice that the frame rate is set to 24 frames per second. While there are additional requirements related to UVs and textures, we won't be checking those as our model uses a single color material. With everything in order, let's export our model. Go to File, Export, FBX. And now, it's time to go to Metaspark. Once the platform is open, go to Preferences and uncheck Automatically Scale Imported 3D Models. Now let's import our model by going to Assets, Import, from Computer, and locate the file. In the Scene panel, add a plane tracker and drag our model into it. The 3D object now becomes a child of the plane tracker, adapting to the real-world surface it's placed on. You may notice that the model appears larger than expected, but remember that we created it with a larger size in Blender. So don't worry, it works perfectly for our effect. With the model selected, go to Properties, click the drop-down next to Animation, and select Create a new animation controller. You'll see a new animation playback controller in the Assets panel with our animation and its properties. For now, we are going to pause the animation. Let's create a method to resize, move, and rotate the object within the effect. To achieve this, we'll use the patch editor. Start by creating consumer patches for each property, position, scale, and rotation, by selecting the object in the Scene panel and clicking the arrow next to each property in the inspector. Okay, now let's proceed with creating the following graphs. To control the position, we'll use the Screen Pan patch, which detects finger swipes on the screen and provides X and Y values based on the 2D coordinates. Use the 2D offset output to capture the difference between the initial and the moving position of the finger. The values returned by this patch are too high and will cause our object to move very drastically in the scene. To achieve a smoother movement, we need to divide these values by another number. In this case, we use 900, but 1000 works perfectly fine too. That is up to you. Just remember that we need higher values than the original ones. You can see that I am using the divide patch with vector 2 type to see the original x and y values. Once our values are divided, we use the unpacked patch with vector 2 type to isolate the data received and get the x and y values separately. Connect these values to the x and z inputs of a packed patch, since we want to move the object along a horizontal plane. Finally, connect the resulting value to the consumer patch that represents the object's position. For controlling scale, the screen pinch patch comes into play. It allows us to resize the object by pinching the screen. The output scale represents the scale of the pinch starting from 1. Connect this value to a packed patch to control each dimension of the object's scale. Lastly, pass the final value to the scale consumer patch. To handle rotation, we'll use the screen rotate patch to detect 2-finger rotation gestures. The rotation output gives us the rotation value in degrees. Multiply this value by -1 to invert the direction and achieve a more natural rotation. Connect this value to the Y input of a packed patch, as we intend to rotate the object along its Y axis. Finally, connect the value to the rotation consumer patch. Let's now create a method to activate and deactivate the animation by tapping on the object. Drag the model into the patch editor to create a patch representing the object. Connect it to an object tap patch, which triggers an action when the object is tapped on the screen. Add a switch tap patch to toggle the animation on and off. Finally, select the animation playback controller and click the arrow next to play inspector to create its consumer patch. Before wrapping up, let's give the model a more robotic appearance. Now that everything is set, it's time to test our effect on a device. And there you have it. We have successfully animated our model. I hope you enjoyed this video. If you found this tutorial helpful, please give it a thumbs up and share it with others who might find it useful. Feel free to leave any suggestion in the comments below, and don't forget to subscribe for more exciting content. Thanks for watching, and I'll see you in the next video.